have you ever looked up at skyscrapers, those massive structures reaching into the sky, and wondered how they managed to stand so tall without toppling over? Take the Burj Khalifa, for example. It's the tallest building in the world at 2,717 feet. To give you some perspective, that's nearly 4 times the height of the Empire State Building. But here's the big question: how do these buildings stay so stable even in the face of powerful winds or earthquakes? Welcome to Mind Drift, where today we're exploring the engineering marvels behind skyscrapers. The birth of skyscrapers. After the Civil War in 1865, American cities like New York and Chicago saw a huge population boom. With land becoming scarce and expensive, architects faced a big challenge: how to house more people in smaller spaces. The solution? Building up instead of out. Instead of spreading multiple low-rise buildings across vast land, architects decided to stack floors vertically. At first, people were skeptical. Could buildings that tall really be safe? Would they withstand the forces of nature? These doubts didn't stop engineers, who forged ahead, building what is now recognized as the first modern skyscraper, the Home Insurance Building in Chicago, completed in 1885. Engineering challenges. Constructing skyscrapers introduced 2 major engineering problems. Firstly, weight. How can the structure support its immense weight without collapsing? Secondly, forces of nature. How can it withstand strong winds and earthquakes? Let's break these down. Supporting the weight. Every building supports a variety of loads: furniture, people, and the structure itself, what engineers call the dead load. The materials used must handle this weight without failure. Traditional bricks and stone simply couldn't handle skyscraper-level loads. Enter steel, a game-changing material that's both lightweight and incredibly strong. Steel frameworks allow skyscrapers to be lighter while still standing tall. For example, the Burj Khalifa, weighing over 500,000 tons, uses a steel-reinforced design to distribute weight efficiently. Without steel, a building of that height would require walls so thick it wouldn't be practical. Battling the wind. The higher you go, the stronger the wind. At the top of skyscrapers, wind speeds can reach over 75 miles per hour. That constant pressure can cause dangerous swaying or even structural failure if not properly addressed. What are the serious challenges engineers face when constructing skyscrapers, and how do they overcome them? The first solution proposed was that the foundations and base of the building should be deep and built in a specific way to handle the immense weight of the structure above them. The initial practical step in the foundation work involves excavating to extreme depths until reaching solid layers underground to build the foundations on them. This is critically important because if the soil where the building is constructed is not strong or suitable to support the foundations, the building may tilt or collapse easily. A prime example of this is the Leaning Tower of Pisa in Italy. From a design and construction perspective, the tower was built with high efficiency, but the one major mistake the builders made was neglecting the soil and the foundations. The soil on which the Tower of Pisa was built was not capable of bearing the load, causing the tower to tilt into its current, iconic state. So, what should be done if the soil cannot support the loads imposed on it? The solution is simple: the soil must be reinforced. A great example of this is the Burj Khalifa. The Burj Khalifa, the tallest building in the world at 828 meters, 2,717 feet, weighs about 500,000 tons when empty. The soil on which the tower was built is one of poor quality and was not naturally capable of supporting such a massive structure. The soil consists of loose sand with no solid ground to build foundations on. To address this, more than 100,000 tons of concrete were poured into the ground, most of it a mixture of concrete and steel. Additionally, over 190 steel-reinforced piles were installed. These piles act as deeply driven stakes that anchor the building securely and connect the foundations to the solid depths beneath the Earth's surface. Aerodynamic shapes. Many modern skyscrapers feature sleek designs that help redirect wind around the structure. Look at the Shanghai Tower with its smooth, twisting form, or Taipei 101, which incorporates a tuned mass damper and enormous weight that counterbalances wind-induced movements. Final touches. Once the steel skeleton is complete, the exterior is wrapped in lightweight materials like glass and metal panels, giving skyscrapers their iconic look. Interiors are divided into spaces for offices, apartments, or observation decks, while the design itself often includes features that mitigate environmental forces. Skyscrapers represent the perfect blend of creativity and practicality, standing as symbols of human innovation. So, the next time you see one of these towering giants, you'll know they're not just buildings, they're masterpieces of modern engineering. Stay curious and see you next time on Mind Drift.